Hello everyone, my name is Shukri Abdi. I'm a student at GMU in HAP 823 with Professor Alemi, and today my Teach 1 assignment is going to be on multi-level regression. So just a little bit about multi-level models, also known as MLMs. They have multiple names, or they're also called or referred to as clustered or nested data models or hierarchical linear models. This method became popular with the availability of powerful computing and software technologies. In trying to determine whether or not you should use MLM, usually if your data is nested or has many levels, you could use MLM as your approach. Unlike OLS, MLM has two error terms. The main difference between OLS and multi-level models is that with OLS, the regression assumes that observations are uncorrelated and regarded as independent from one another. With multi-level models, parameters vary at more than one level. Example would be a model on patient satisfaction that contains measures for individual patients as well as measures for clinicians within which the patients are grouped. All levels are also considered random samples. When starting to build your model, it's important to determine the variation. So multi-level models account for variation in intercepts and slopes. So in my second bullet point, you can see that within my two-level model, we've got two groups. One group is within group and the second is between group. And with the variance component model formula, I'm trying to determine the variance among patients seen at the same clinic, which would be my within, and also the variance between patients seen at different clinics. And the Y in the formula indicates your patient satisfaction, the I indicates the patients, and the J indicates the clinics. In the bottom right-hand corner, you can see that I've just put together a very basic and simple two-level hierarchy. Level 1 would be the patients, and level 2 would be the clinic. So when building your model, you want to determine the random intercept and slope model. So the various component model plus a simple regression model will give you this formula here, which is referred to as the random intercepts model. This allows for the mean performance to vary. In our case, it wouldn't be school, it would be the clinic, mean performance to vary. You can extend the random intercept model by adding level 2 variables down below. And you can also find the slope model, which allows for the relationship between Y and X to be different from clinic to clinic. So now we're going to go into our SQL portion, and I'm going to show everyone how to approach multi-level modeling regression in SQL. So for this assignment, we've been asked to approach multi-level modeling through SQL, and we are provided with a data set called lung cancer morbidity. I went ahead and downloaded the data, and I've opened it here in Excel. Our first column is the ID column. When we're running our SQL code, we're going to actually have to select distinct because I believe there's duplicate IDs in here. We've got the second column, which is dead in 6 months, which we're going to be using when solving for our in order to calculate the probability of mortality. We've got medical centers listed out. We've got survival days. We've got an indication of lung cancer, 0 being no lung cancer, and 1 being yes, the individual does have lung cancer. And what we also have listed out separately are the comorbidities that an individual may have in addition to having lung cancer or not.